Hi there and welcome back. Today we're going to look at section 4.3, which is on curve sketching for polynomial functions. So in this section, we're going to take what we've learned in our last couple of sections about the first derivative and second derivative that helped us find different characteristics of the function. Remember that the first derivative helped us find where the function was increasing and decreasing and where there were max and mins. And then the second derivative helped us find where the function's concave up and concave down, and also any points of inflection. So today we're going to put all of that together and look at how we can sketch a polynomial function given this information. So that's our objective for today, is we're going to look at sketching a polynomial, plus sometimes a little bit differently, maybe given a function and answering some questions about it as well. All right, so our concepts and definitions today, we've got a couple of things, most of which we already know, but we're just kind of putting it all together. So first, let's just remember what a polynomial function looks like. Okay, it's a smooth, continuous curve, and the domain is all real numbers, which means the derivative and the second derivative exist for all the x's in the function. So there are no problems with finding a first and second derivative for polynomials. Polynomials, we're just going to use the nice first derivative rule we learned, which was the power rule. Okay, so that's the good thing today. Now, in order to sketch, we're going to have to do a couple of things. So we need to be able to find all the max and mins, all the points of inflection, and then any other values that are given to us. So to sketch a graph, if you're given a function, you're going to have to do a couple of things. So this number 2 goes through this list with you. Okay, so we're going to do that in just a minute. First, you're going to find the first and second derivative because you need those two bits of information to find what's coming up next. B, you would find the critical values of the function. And remember, the critical values of the function are where f prime of x equals 0. Okay, so put that here, where f prime of x equals 0. We did that in section 4.1. All right, now, part C says, use the critical values as endpoints, find the intervals where f prime of x is greater than 0 and where f prime of x is less than 0. So that's when we're going to sketch those on the number line and find, where we have the positive values and negative values. So above where the derivative is greater than 0, that means where the derivative is positive, that's where your function f of x is increasing. Okay, so I just wrote that there so you know when you find where the first derivative is positive, that's where the function is increasing. Where the first derivative is less than 0, that means where the first derivative is negative, that's where your function is decreasing. Okay, so first derivative is telling you about the actual function. All right, once you do your number line and find your plus and minuses, then you can locate any local extrema. Okay, remember wherever there's a change from increasing to decreasing. So we'll go through that, but we've already done that in section 1. Then we're going to go through the same process again with the second derivative. So we're going to find the hypocritical values of f, which remember that's where the second derivative equals 0. Okay, so we're going to do the same thing we did here, but we're going to use the second derivative. Then on the next page, we'll continue with part F, which says, using the hypocritical values as endpoints, find the intervals. So again, we're going to do our number line. We're going to find our plus and minuses. And wherever the second derivative is greater than 0, that's where the second derivative is positive. That means that's where your function, the original function, is concave up. And where the second derivative is less than 0, that means where the second derivative is negative, that's where your function is concave down. And then wherever there's a change in concavity, those are your points of inflection. Okay? Then we're going to take all of that information and any other specific points given to you, such as x and y intercepts. Sometimes they'll give you some ordered pairs to plot, but any other points, and we're going to sketch the graph. Now, when we sketch the graph, it's not going to be perfect. It's not going to be the exact graph because we don't have all the information, but we have quite a bit that will help us get a good idea of the shape of that graph. Okay? All right, so we're going to start with problem number 1 and go through all these steps basically in order to sketch the graph. Now, there's no particular order to this, so, I know in number 2, it gives you a through h. Okay, you can, I mean, you have to find the derivatives, you have to find this information, and then you will also have to, plot other points and things. So the order isn't hugely important, but you just have to have all of this done before you can sketch. So we're trying to give you the best order possible to do that, okay? All right, so we're going to go to number 1, which is a polynomial function. Here's your function, negative 4x cubed minus 30x squared minus 72x plus 7. And we're going to go through all of this and figure out how to sketch the graph without putting this in your calculator. Now here's the thing. We're starting with this function that you could graph on your calculator and find all this. However, you'll see on the next few pages coming up, some of the problems you're given are not given to you in this respect. Okay, so if it's not given to you where you can graph it, then you have to know how to do it. So please don't fool yourself and just graph this and say, I don't need to do this. You will, because you'll see in numbers 2 and on coming up that you don't always have access to putting the function in your calculator. Okay? All right, so always we're going to start when we're graphing is find the first and second derivatives, because we're going to use those coming up in the later parts. So let's just go ahead and do that. So we need the first derivative. Just use your power rule. So negative 4 times 3 is negative 12 x squared. Subtract 1 from the exponent. Same on the next. Negative 30 times 2 is negative 60. X to the first, subtract 1. This is your linear term, so the derivative of negative 72x is just negative 72. And then that's the constant, so its derivative is 0. All right, so now we're going to find the second derivative, which is just the derivative of the first derivative. So same thing. Negative 12 times 2 is negative 24. X to the first, so you're going to subtract 1. This now is your linear term, so the derivative of negative 60x is negative 60. And then that's derivative of negative 72 is 0. So there's your first and second derivative. Okay, so for part B, we're going to be using the first derivative because it's asking about increasing and decreasing. That has to do with f prime, okay? If you look at part C, it wants you to know where the function is concave up and concave down. That means we're going to be using the second derivative. But we're going to really do the exact same things for both. Okay, so there's no difference. It's just which function you're starting with. All right, so let's do the increasing and decreasing. So we're going to take negative 12x squared minus 60x minus 72 and set it equal to 0 to find the critical values. Okay, so that's always the first thing we're going to do. We have to find the critical values so we can put them on the number line to find where our function's increasing and decreasing. All right, so I'm going to factor out a negative 12. I always like to start with my first term being positive, so if all else fails, I can factor out something negative. So if you factor out a negative 12 from each term, you're going to be left with x squared in here. Negative 60 divided by negative 12 is a positive 5x. And negative 72 divided by negative 12 is a positive 6. And then we can factor that. Factors of 6 that add up to give me 5 would be 2 times 3. So x plus 2, x plus 3 equals 0. Set each of those equal to 0 and get your critical numbers. So if x plus 2 equals 0, one of your critical numbers is negative 2. And if x plus 3 equals 0, your critical number is negative 3. Now, negative 12 is not a critical value. You're solving for x. Okay? When you're solving, you solve for x in equations. That's just a number. It's always negative 12. That's not a variable. Okay? So that you don't set that equal to 0. That's not one of your answers. All right. So now we're going to take our critical values and put them on the number line. Remember, we're testing the derivative, okay? So I'm going to use this to figure out where the function's positive and negative. This is the easiest way for me to do it. You can use this, you can use this, put these numbers in your calculator, but functions. You can pretty much do these in your head. All right, so we're going to put -2 and -3 on the number line. Make sure you put them in the right order. So -3 is to the left of -2. And then we need some test points. So pick something less than -3. I'll pick -5. Pick something between -3 and -2. Can't get a whole number in there, so we'll just do -2.5. And then pick something bigger than -2. I'll pick 0. 0 is always nice. Okay? All right, so all we're going to do is know whether or not this function is positive or negative in these regions. So less than -3, what's going on? So we're going to test -5. Now this is always negative. If you put a -5 in here, -5 plus 2, that's going to give you a -3. All I care about is that it's negative. And if you put a -5 in here, you're going to get a -2. Okay, so this is also negative. So we have a negative times a negative times a negative. 3 negatives multiplied together is negative. Okay, I don't care about the value, just the sign. Okay, just the sign. All right, now pick -2.5. Let's see what's going on between here and here. If you put -2.5 in here, -2.5 plus 2, that's still negative. So we got a negative, negative. But when you put -2.5 in here, 3 is bigger, so this is going to become positive. So now you have a negative times a negative times a positive, which is positive. Okay, so everything in here is positive. Now we're going to pick 0. If you put 0 in here, this is positive. If you put 0 here, this is positive. A negative times a positive is back to negative. Okay, now I told you this earlier, but just because just because most of the problems we do seem to alternate signs, you can't assume that, okay? Especially when you're doing these kinds of problems, a lot of times you're going to get a negative, negative, then positive. So don't assume that this is always going to happen where it alternates. You have to test it, okay? I don't want you to get them wrong because you're feeling pretty good about the fact that you always see these things alternating. That's not always true, okay? All right, so since we're using positive and negatives for the increasing and decreasing, I don't want us to get confused to use positive and negatives also for concave up and concave down. So remember, for increasing and decreasing, I use the up arrows and the down arrows, okay? Increasing is up, decreasing is down. So while I put this here for you to understand the signs, when I see a minus sign for first derivative, that tells me where my function is decreasing. Where I see a plus sign for first derivative, that tells me where my function is increasing. And over here, this tells me my function is decreasing, okay? So the question asked, where is my function increasing and decreasing? So I'm going to say f of x is increasing. Okay, now I need my intervals. So the only place it's increasing is right here between -3 and -2. So that's the only interval where it is increasing. Then where is f of x decreasing? Okay, that's where the minus signs are. So between -infinity and -3. And then also from -2 to positive infinity. Okay, so that's the answer to what it asked me there. But I did that using the first derivative test and finding critical values. All right, so now we're going to move to second derivative, concave up, concave down. So remember what the second derivative was right here. So now we got to find the hypercritical values. So we're going to take -24x minus 60, set it equal to 0. Okay, that's what we're going to do to find the hypercritical values. Okay, so from here on, we're going to do the same exact thing, except now we're using this function, okay, the second derivative. All right, so we're going to solve that for x. So this one's a little bit easier. So -24x equals 60. Divide both sides by -24. And that will reduce to -5 will go in, 12 will go into both of those, 5/2. Okay, so there's our hypercritical value right here. So now we're going to take that on the number line, only one. This is testing the second derivative, okay? The second derivative. So I don't have factors here, so I'm just going to use this to plug in my x's, okay? And again, it doesn't matter. Here I use the factored form because to me that's easier. But if I don't have factored form, I just use the original function. So I need to pick some test points, pick something less than negative 5/2. That's negative 2.5, so I'll pick negative 3. And pick something greater than negative 5/2. 0 is always easy. All right, so if I put negative 3 in here, negative 3 times negative 24, that's a positive 72. 72 minus 60 is a positive number, so over here is positive. If I put 0 in here, negative 24 times 0 is 0. 0 minus 60 is negative. Okay, so now you can see why I don't want to use plus and minus signs for both because it's confusing. How am I going to know which one's which, right? So for concavity, I use the cups. Okay, I use, or the U, however you want to think of it. Concave up, I go like this. Concave down is upside down. Okay, so for this number line, I'm actually thinking of this and this for concave up and concave down. So always when I teach this, yes, you're still looking for plus and minus signs, but for me, I like to know, when I see these arrows, I know that's a first derivative. And when I see these symbols, that means second derivative, okay? So that's why I do that, so I can tell them apart, because we're going to get ready to graph right now, and we need to know the difference in those. All right, so where is this function concave up, concave down? So f of x is concave up, wherever there's that plus sign, where the second derivative is positive. So everything to the left of negative 5/2, so like that. And then f of x is concave down wherever the second derivative is negative. So that's the right side over here. So from negative 5/2 to positive infinity. Okay. So notice we did exactly the same thing. We didn't change anything. We're just doing the first derivative here, second derivative here. Okay, but you've got to keep up with increasing parts, decreasing parts for what's coming up on the next page. All right, so let's look at part D. Find all the local minimum, local maximum, and inflection points. Okay, so local mins and local maxes happen where there is a change from increasing to decreasing on the first derivative. You have to know which one's which, so let's talk about that. So here's our first derivative graph. So the only possible max and mins are your critical values. So negative 3 might be 1 and negative 2 might be 1. They may or may not be. We have to look at what's going on around them. Okay, so this is just using a little common sense here. So if we're approaching negative 3 and we are decreasing, that means we're drawing the graph this way. Decreasing goes down, right? And then on the right side of negative 3, we're supposed to be increasing. So we're decreasing here, increasing here. So this value, wherever it is, has to be a minimum. Okay, it went, right? Look, it went from decreasing to increasing. So that's a minimum value. So here's our minimum at x at negative 3. That's a min. Okay. Then what happens at negative 2? Well, at negative 2 on the left side, we're increasing. We're going up. And then when we get to negative 2 on the right side, it says decrease, which means we're coming down. So at negative 2, we were increasing and then we were decreasing. So what is that? That is a maximum. So here is a max. If, for example, we went decreasing to decreasing, then that's not going to be a max or min. So the signs have to change. If there's no sign change, it's definitely not a max or min. Okay, so you've got to pay attention to the signs. All right, so we have x equals negative 3 is a local min. Okay. X equals negative 2, we said, is a local max. Now, points of inflection. Points of inflection are the same exact thing except for the second derivative. So all we have to do here, which is only one point of inflection, we don't have to do it up or down or whatever. It doesn't matter. All that matters for points of inflection is there's a sign change. You got to go from concave up to concave down, or concave down to concave up. Either way, those are called points of inflection. So there is a point of inflection at -5/2 because there's a sign change there. Okay, so at x equals -5/2, that is a point of inflection. Okay. Point of inflection, inflection point, same thing. Okay, it's just the way you say it. So, all right. So that's our answers to part D. Okay, so now we're getting ready to sketch the graph. So let's remember, what we need to do. And I want to add one little thing in here because I think it's helpful to kind of see this, all right? So I always, before I start, okay, I will dot in my boundaries. Okay, so let me explain that and then we'll kind of go through it. So over here, I'm going to say dot in boundary lines at any critical or hypercritical values. Okay. All right. Then we're going to identify the areas that are increasing, decreasing, concave up, concave down, right? So we're going to identify these on our graph in a minute. And then as the direction said, we're going to plot any other known points. And then we're going to sketch. Okay. Now, I'm going to change this graph up because I'm looking at these numbers. So we have to put our boundaries. Remember, these were our critical numbers and hypercritical, right? So -3, -2, -5/2, they're all real close to each other. So if I try to put them on here, they're all between these little two lines here. So I don't really want to do that. So it's still going to be tight, but let's change the horizontal, the x-axis, to go by ones every 2 lines. So let that be -1, this be -2, -3, and -4, okay? So otherwise, it's going to be really cramped. It's still going to be cramped, but not as cramped. We can leave this the same. I know they're supposed to be the same, but for now. Okay, and the only reason I'm leaving them the same is because our other point, the only other point that I know on this function is the y-intercept. The y-intercept is the constant value because you're letting x be 0. To find the y-intercept, you always let x be 0. So all of these are 0. So that's your y-intercept. So we know that, okay? But, so that's why I'm not changing that because I got to plot 7 up here. Otherwise, I would change that too. Okay, so the dot in the boundary lines. So here's our critical values. So -3, -2, and -5/2. So typically do this with a pencil, just in case I mess up or have to erase anything. So I'm going to put a dotted line for this boundary. Okay, I'm going to put a dotted line at -3. That was my other critical value. I'm going to go higher because I got to get up higher here. And my hypercritical value is -5/2. So you can see why I did what I did because it's already pretty tight. Because everywhere between these boundaries, something's going to change on your graph. So something's going to change in here to here. And then we're going to go from here to here. Something's going to be different. And then from here to here. And this is the rest of the graph. So the left side and the right side's got a lot of area, but not these two middle ones. All right. So now we're going to go back and identify the areas that are increasing, decreasing, concave up, concave down. So that goes back to your number lines, okay? All right, so let's start with increasing. Where were we increasing on our graph? Only between -3 and -2. So in every area, every boundary area that's between -3 and -2, we're going to increase. Now, I got to draw the graph way up here, so I'm going to put my symbols down here. So I'm going to be increasing in this area and this area, right? Because both of these areas are between -3 and -2. So each area gets its own symbol. All right, and then where were we decreasing? In the other areas, right? So we were decreasing to the left of -3 and to the right of -2. We were decreasing. So to the left of -3, so all of this area over here is decreasing. And to the right of -2 is all of this area we are decreasing. Okay, so this whole area over here. This is not a boundary, okay? Only the dotted lines are boundaries. So you have to have something in each of those areas. We're going to do the same thing for concavity now. Where is the graph concave up, concave down? Okay. Graph is concave up to the left, less than -5/2. So look at your boundaries. Here's -5/2. So this area is going to be concave down. I'm sorry, concave up. And this area is going to be concave up. So we're going to put a U here and a U here. Okay. And then to the right of 2.5, remember that's where it was concave down. So everything greater than -5/2. So that would be here and in this area. So these are concave down. So for every piece of the graph, every boundary, you have an increasing, decreasing, and you have a concavity, right? So you see that there. Notice from one to the other, something changes. From here to here, I stayed concave up, but I changed from decreasing to increasing. From here to here, I'm still increasing, but my concavity changed. And then from here to here, my concavity stays the same, but I go from increasing to decreasing. Okay, so now we got everything done, and now we're going to plot that other point, which is the y-intercept. Okay, that's the only other point given to me in this function. I'm not going to solve for x. You could, but I don't. This is too hard to do. Usually they give you points, so don't worry about that. Just whatever is available to you, that's all you need. Okay? All right, now the fun part. We got a sketch. We got a sketch, and the only thing that has to be true about our sketch is we've got to end up through this point. So I want to think about this a little bit before I start drawing. Okay? So remember my 4 little areas about concavity? So remember that this is concave up. If I've put it together. So on this side of concave up is decreasing. So this is decreasing concave up. This piece is increasing, but it's concave up. Okay? And then you're decreasing one of these two parts. This is increasing and concave down, and this is decreasing concave down. So if you need to write that in, that's fine, but you got to know these shapes. That's what we're getting ready to do right now. So this is decreasing concave up. This is increasing concave up. This is increasing concave down. And this is decreasing concave down. Okay, so looking at those shapes, that's what we got. 4 possibilities. That's what all this is down here. So we have to have our graph have these shapes. All right, the problem is because I have to go through here, I can't start too low. So I'm going to show you why that is, because otherwise I can't get to this point. So before you start sketching, just kind of make sure you see where these other points are that you have to go through. It's the only point I really have to go through is right there. So right here, if I do decreasing concave up, which is this shape, if I did it down here, okay, I can put it anywhere because doesn't matter where you put it, just decreasing concave down. It can go way like that, doesn't matter. It can go like this. But if I do it down here and then I go increasing concave up, which is this, so let's say I go like that. And then here I got to go increasing concave down. Okay. Oh, sorry. Increasing concave up is this one. So here I got to go like that. Then I got to change to that. So if I'm not way up here for this last one, I got to go through here. I got to be decreasing and concave down. I got to be way up here. Okay? So I always draw my graphs from left to right because, that's the way we sketch, right? We sketch from left to right. However, I do see that here, since I've got to be decreasing concave down, which is this, and I got to go through this point, I may want to at least do this, because that's decreasing and concave down right there. But now all these pieces have got to touch, okay? So what is this here? So again, if I started on this side, decreasing concave up is right here. So I can put that way up here if I want. I can go like that. And then I can do increasing concave up, which is this. Okay. And now I can keep increasing, but go to concave down, which is this piece. So from here to here, I got to be shaped like that. Okay. So there's my graph. It's not always pretty, but we are decreasing concave up. From here to here, increasing concave up. From here to here, increasing concave down, and then decreasing concave down. So notice what we just did. We had, doesn't really look like it, but there's our minimum. Here's our maximum. And then right there is that point of inflection where it changed from concave up to concave down. Okay? Again, it's a sketch. I know the max should be kind of more in the middle, okay? But that's just kind of the sketch. So because we have this function, so that's a good sketch. I don't know if it's perfect or not. It's probably not, okay? But it has the shape that we want. That's what we're trying to get you guys to do. So now that I have that, I just want to show you. If I put the function in my calculator, I'm going to put this in my calculator, okay? I already have it in there from earlier, so I'm going to go to y equals, okay? Get you to see that. There we go. All right, so I've got the function in there. Now, if I go to graph, my standard 10 by 10 window, this is all that shows up, okay? So that doesn't look like this. But remember, this was the max at -2. And if I go to the table and look at what the value is at -2, that point is at -260. This is -263, way up high, okay? So I'm going to change my window so that my y max is higher than 63. I'm going to make it, let's say, 75. And now when I graph it, I should see a little bit more. There we go. All right, so see, we did pretty good. We got the decreasing concave down over here. Then it went up a little bit. Now mine looks a little higher than that, but that's fine. Remember, we're zoomed way out. And then it came all the way down and crossed at -7 and then went through probably before 1. So I probably should be a little bit steeper here, right? But again, this is just a sketch, okay? We're just trying to see that we can figure out the shapes of these graphs without actually using that calculator. So it is kind of cool how that works. All right, so I'm going to stop now and do part 2 so I can not have such a long video. So we'll pick up on part 2 with number 2 in just a minute.